This is section 6.3, and we're going to look at the surface area of prisms and cones. So our learning goal for this section is that students will understand how to calculate and use the surface area of prisms and cones. So let's get started. Remember when we talk about a pyramid, what are some of the things that define a pyramid? Well, first of all, the base of a pyramid is a polygon. And here's a new word, the lateral faces. Those are the triangles that make up the pyramid. So everywhere where you see a triangle, that is actually a lateral face. To make a pyramid, it also has to have a common vertex. You couldn't have those triangles coming up and meeting at different places. When we look at a pyramid, there's a couple of other things that we need to know. First is the height. So the height of a pyramid is the perpendicular distance between the vertex and the base. So that means I'm drawing in this perpendicular line, and it must be perpendicular, to the base. So it has to form a 90-degree angle. Basically, it's just saying the height has to be straight up and down. The other piece that we're interested in is the slant height. The slant height of a pyramid, looks like this kind of got replaced here, is represented by the letter L, and it's usually a cursive L, okay? And it's the height of any of the lateral faces. So remember, the lateral faces were the triangles. So if we look at this triangle here, the slant height is the height of that triangle. So picture that triangle sitting right in front of you. It would look like this. The slant height is the height of that triangle. So let's do an example where we have to find the slant height. So remember, anytime we have 90-degree angles, we're going to be creating right triangles, which is good. So let's look at this picture over here for a second on the right. If we want to find the slant height, it kind of helps to visualize this little triangle in here. I think this is a good little sketch. So for any square pyramid, the slant height can be found using a right triangle that's formed by the height and half of the base. So here's the height, and then this segment here is going to be equal to half the length of one of the sides of the base. So we're making this right triangle, and then this little segment right over here is the slant height. So in this particular example, we want to find the slant height. We can see if we draw in this little segment right here, its length must be 100, right? So we can use the Pythagorean theorem, and we can say that 100 squared plus 100 squared, the two sides of that right triangle, must equal the slant height squared. So now let's calculate this. 100 squared is 10,000. And another 100 squared is another 10,000. And that equals the slant height squared. So add those together, we get 20,000. And then we have to take the square root of both sides to get the slant height. And the square root of 20,000, I'm just going to approximate that with a decimal value. The square root of 20,000 is about 141.42. So that's how we can go in and find the slant height. And we're going to need that slant height because we need it in the formula to calculate the surface area. So if we have a pyramid, we say that the surface area is equal to the area of the base, whatever kind of shape it might be, plus 1/2 times the perimeter of the base times the slant height. And we'll talk in class, we'll investigate why this is the surface area formula for a pyramid, but for now what I want you to do is just get the formula down and we'll practice plugging in our values and using the formula. If we want to write it in symbols, we write it like this, where capital B represents the area of the base, capital P is the perimeter of the base, perimeter of the base figure, whatever that figure might be, and then of course L, like we just talked about, is the slant height. And I would highly recommend that underneath you write down what these variables stand for. Write it both in words as a formula, in symbols as a formula, and then also write down what those symbols stand for. So capital B, the area of the whole base, perimeter, distance all the way around the base, and then the slant height. Now you might be wondering why this is a 1/2, but think about what other area formulas have a 1/2 in it and how that might apply to this situation. All right, so let's do an example. Let's find the surface area of this pyramid. So we can see some of the variables that we already have been given. We can see that the height is 4, and we don't yet know the slant height, but I know that each side of my pyramid here is 6. So that means that the base of this pyramid is a square. So let's write down some of the information that we have. Okay, first of all, capital B, the area of the base, would be 6 times 6, or would be 36, right? Because the base is a square. We can also find the perimeter. The perimeter of the base would be 6 plus 6 plus 6 plus 6, or 4 times 6, so the perimeter would be 24. So we have capital B, we have capital P. The only thing that we don't have right yet is the slant height. So again, we're going to create that little right triangle so we can make the slant height. Now notice, in that right triangle, we have a 3 and we have a 4. And hopefully you remember that if you have two legs that are 3 and 4, the hypotenuse has to be 5. But if you don't remember, we could work it out. 3 squared plus 4 squared would equal the slant height squared. So that's 9 plus 16. But 9 plus 16 is 25. Take the square root of both sides. And my slant height must be 5. All right, so now I have all the variables that I need, and I can plug that into my formula. So the surface area is going to be the area of the base, which was 36, plus 1/2 times the perimeter, which was 24, times the slant height, which we just found was 5. So let's simplify that. That's going to be 36. Half of 24 is 12 times 5. So we have to do the multiplication first, and 12 times 5 is 60. And so 36 plus 60 is 96. And we're again talking about surface area. So this would be 96 square feet. Great. So let's talk a little bit about cones. A cone is a lot like a pyramid. We've looked at them already. And it has a circular base and a vertex that is not in the same plane as the base. All that's saying is that the vertex here has to be somewhere above the base that is a circle. So that vertex has to be above it. That's what makes a cone a cone. The height, just like a pyramid, has to go perpendicular to the base, and it's going to meet the base at the very center of the circle as long as it's a right cone. And right cones are going to be the only kind of cones that we work with. So here's the height. Again, it's perpendicular to the base, so it must be perpendicular to the radius. This outside part around the edge, that's called the lateral surface. We don't call it a lateral face because it's curved. We call it a surface. So all of this outside part, the part that is the ice cream cone, would be the lateral surface. And so then the height, of course, is perpendicular. We also have a slant height in a cone as well. Okay, so the slant height is this length along the edge of the cone. So the slant height of a cone is the distance between the vertex and a point on the base edge. So if I look at the base edge and a point right there and the vertex here, and I connected them with a line, that is the slant height. And the slant height is also going to form a right triangle just like it did with a pyramid. So let's talk about the surface area formula for a cone. All right, so we still have to find the area of the base. That's going to be the area of this little circle in here. But then we have to add to that the area of the sector that makes up the surface of this cone. So the area of the base, by the way, this base is a circle, right? So the area for a circle is pi r squared. But then what we're going to do to find the area of the sector is we're going to take pi multiply it by the radius, and multiply that by the slant height. Okay, so we'll talk again more about where this formula is coming from and how it is developed when we meet in class. So the formula for the surface area of a cone is pi r squared plus pi rl, where r is the radius of the base and l is the slant height. So let's do an example. Let's find the surface area of this cone. So remember, let's write down our formula. Surface area is pi r squared plus pi r L. And let's see which variables I have and if I need to find any. So I can see right here that the radius is equal to 4, and it's already given me the slant height, which is equal to 6. And that's all I need. Pi is just going to stay pi in my formula. So the surface area is going to be pi times 4 squared plus pi times 4 times 6. So now we simplify. 4 squared is 16, so we have 16 pi, plus 4 times 6 is 24, so we have 24 pi. 16 plus 24 is 40, so we can say that the surface area of this cone is 40 pi square inches. Now that is the surface area given in exact form. If I wanted to, I could come up with a decimal approximation for that surface area by plugging in 3.14 for the value of pi. So if I did that, if I multiplied 40 times 3.14, let's see, what would we get? Pull up our calculator here. 40, oh, wait a minute, try that again. 40 times 3.14 is equal to 125.6. So this is about 125.6 square inches. Okay, so either one of these answers is correct. Pay attention to the directions. If I want it in exact form, you want to leave pi in your answer. If I want it rounded to the nearest whole number or the nearest tenth, then you're going to plug in pi equals 3.14 and multiply it out. All right, one more example. Let's find the slant height and then the surface area of this cone. All right, so let's start with our formula. Surface area is pi r squared plus pi r times the slant height. And in this case, I can see that the radius is 12 right here, but I don't yet have the slant height. So we got to find that. So we'll use this right triangle right here to help me find the slant height. So 5 squared plus 12 squared equals the slant height squared according to Pythagorean theorem. If I know my triples, I already know that's going to be 13. 5, 12, 13 is a triple, but we can work it out. This will be 25 plus 144 equals the slant height squared, and 25 and 144 adds to 169. So that's the slant height squared. Taking the square root of both sides, I get 13. The square root of 169 is 13. So now we have my radius, we have my slant height. All we got to do is plug it into the formula. Pi times my radius, which was 12, plus pi times my radius times my slant height. So now we just work it out. 12 squared is 144. So we have 144 pi plus 12 times 13. Let's see, I don't know that one off the top of my head, so we'll work it out here. 12 times 13 is 156, so plus 156 pi, and then I have to add these together. So that's going to be, 300 pi square feet. Now, again, this is the exact answer. If I wanted to round to the nearest whole number or the nearest tenth, I would multiply 300 times 3.14 and get that decimal approximation. So 300 times 3.14 is about 942. So 942 square feet. Again, 300 pi or 942 square feet. Both of those would be correct answers. Okay, so I want you to get all those examples down, go back, complete your summary, and then your left-hand column questions, and that'll wrap up the notes that you need to take for the section. We'll talk about developing those area formulas in class, and we'll practice using them to calculate some surface areas.